and welcome to Tinkering with Edkelar. Well, normally I start video production after I finish the project, but this time I got one delay after the other and I'm running out of filler projects, so here's part 1 of 2 of a portable turntable, a Perpetuum Ebner, or PE for short, model Musical 5V. This particular line was made by the company and its successor for quite a few years, in some slight variations. Mine here is a single tube construction with an ECL 82 triode/pentode tube that is doing pre and power amplification. Earlier versions had 2 tubes instead. I got this one free as is. And oh boy, was it as is indeed. The turntable comes in a carry case. As you see, the case outside is a bit worn and I would like to put on a fresh cover. The top part contains the amplifier, speaker and power supply. The bottom has the turntable. The halves can be separated at the hinge. Before I plug it in, I'm of course taking it apart. You know, the whole free for pickup thing sounds a bit sus. The amplifier section looks okay. Everything is lined up neatly on the chassis. Feels like a bit of a stretch to call it that, but it's the usual tube construction. I made sure to read the tube markings before I dusted it off this time around, and sure enough, the writing came right off with the dust. Now to take a peek into the turntable section. Taking the platter off first. Quite a bit of mechanics under there. Is this... Oh! According to the manual, this is indeed an automatic record changer. Wow! But it seems to be missing the axle for that, and the weight to put on top of the record stack. I might have to remake that. So, let's take a peek. There's quite a bit of rust and lots of dust all over the inside. Looking at the motor next. Uh-oh. I think something exploded in here. Not sure how that would happen, but I fear the motor is in dire need of new coils. The ones that don't look all tangled up are on a very brittle bobbin. So, OpenSCAD to the rescue. The model for the bobbins is a bit complicated. They have to fit and be sturdy enough for the motor. After unwinding one of them to count the number of turns, I'm rewinding all the coils with some new wire. I checked, they all share the same wire diameter and winding directions. And since they are all equally dense, I assume the same number of turns too. And as quickly as 1, 2, 3 weeks, I got the motor stator rebuilt. I did replace the run cap too for good measure. It was looking like a paper foil one, and based on that coil damage, I didn't trust it. I put in the freshly cleaned rotor with a drop of oil and connect the motor to my insulation transformer. Now to connect the wires back to the run capacitor board and give it a try. Well, nothing is not much at all. Bummer. A quick check reveals an unexpected issue. The 2500 ohm power resistor is open. Wow! Based on the carnage, I would say direct lightning strike maybe? I put in a 3K9 power resistor for now, just to see if the motor turns at all. And yes, it runs! But even after only a few seconds, the resistor is so hot that you can't even touch it. Yikes! Is that normal? Even connecting 4 10K resistors in parallel to get close to the original one didn't help at all. Some more research needed. The old value might not fit the new coils. Up next, the amplifier section. The primary side of the transformer measures open between some of the connections. I see a pattern here. But since the transformer at least looked pretty normal, I decided to unwind and reuse the wiring in this case. The paper roll on a drill is slightly improvised, but very effective. I might make myself a jig for that eventually. And quite a bit of winding later, I can repack the core. Looking good! And now to the amplifier. It is a rather simple circuit that includes a bit of tone control, the speaker is in great condition, no tears, just very dusty. I use a small vacuum cleaner to get that out of there. The laminates of the impedance matching output transformer are rusty to the point of bulging out. I better get those cleaned up. At least the coils measure okay this time. And cue the recapping. I replaced pretty much all of the capacitors. The paper ones looked physically damaged, and other ones measured quite a long way out of tolerance. Good riddance. The volume potentiometer presented yet another issue. One of the pins was already loose and another one came off when I removed it from the chassis. These pins are riveted to the base plate and the rivets just snapped in two. After cleaning the surface, I ever so slightly drilled out the holes and put in new rivets. Why not just replace it? Because it's one of those obnoxious 4-pin ones that have a center tap. those are not around these days. I tried my best to hide the new main filter caps in the old can again, but they are ever so slightly too long. I hate it when I have to use tape, but I don't see a good way of keeping them from flapping around outside the case otherwise. I also replaced the old rectifier. I think that's a selenium one. Not sure, but I've read that they tend to go poof with age. The only one I found in my stash that can handle 300 volts fits nicely. The fuse holders and voltage selection switch are up next, and boy is there a layer of soot and oxidation on these. I had to Dremel the fuse holders to get the contact resistance below 1 ohm again. Brrr. And after finishing up the transformer connections, putting power to it for the first time. Okay, 300-ish volts on one output and 7-ish volts on the other winding. Looks good. Now, with the rectifier and filter caps connected, I can see DC voltage on the B+ line. Nice. But another the transformer now heats up considerably. which is weird because other than the caps, there is nothing that should draw power yet. It took a bit of poking and prodding, but I found out that my rectifier had one diode that was pretending to be a short. So what I ended up with was not a full bridge rectifier, but rather an interesting combination of one half wave feeding the DC bus and the other being shorted back into the transformer. The only other rectifier for more than 100 volts I had around was a bit of overkill, but hey, 1600 volts and 68 amps maximum should work fine, right? The final step here is to add the tube and speaker to see if we have anything on the output. During my first try, I must have shortened something on the grid of the power tube because the power resistor got quite hot. This is also where I found out that these resistors don't provide much in the form of electrical insulation. Zap! When powering up a second time, everything was normal though. Only about 40 milliamp of current draw. Time to put in a signal. And yes, I got a sine wave output. Success! Now this is where I want to end part 1 of the restoration effort. Part 2 will have the case and mechanical part, but since I'm still waiting for some parts in the mail, well, no idea when that will happen. Sorry. There might even be other projects in between. Anyhow, I hope you enjoyed this episode. See you next time! The volume presented, it's presented, not presented. There's an E missing in there.